The canary in the mine is the storm, right, that just washes everything away. There's a whole island nation in the Pacific, Kiribati. They're thinking about just evacuating the entire population.
Welcome to Today I Learned Climate, the show where you learn about climate change from real scientists. I'm your host, Laur Hesse Fisher, from the MIT Environmental Solutions Initiative. You might have heard about how hurricanes are going to get worse with climate change, but why is that, and how will that impact us?
I'm Kerry Emanuel. I'm a professor of atmospheric science, and I've been at MIT for 38 years.
Professor Emanuel works at the MIT Department of Earth, Atmospheric, and Planetary Sciences, where he studies hurricanes.
How do they work? Why do they behave the way they do? And can we make better forecasts of them?
Let's dig right in. First, how do hurricanes work?
So hurricanes are enormous heat engines. They convert heat that they extract from the ocean into wind energy. The faster they can extract heat from the sea, the more powerful they can become. So what happens when a hurricane gets going is the wind starts to blow harder over the ocean, and that evaporates more water.
This evaporated water, or water vapor, starts to condense and form a tall cloud on top of the ocean.
So when water vapor condenses, it releases the heat back to the atmosphere, and it heats the air. So you're heating the air in the middle of the hurricane. That makes it want to rise. It draws in air from around it. The air spins, and the wind blows harder. And the wind blows harder, you get more evaporation, more clouds. You're off to the races.
This is the origin story, the recipe for one of our climate's most powerful threats. Just really quickly, we hear cyclones, hurricanes, tropical storms, superstorms.
Yeah. The vocabulary is terrible. In the science world, everything you know is a hurricane is called a tropical cyclone, no matter where it occurs in the world. In the Atlantic and the Eastern Pacific, there's a regional name that comes from the pre-Columbian inhabitants of the region. Huracan was a god of evil, and it evolved into hurricane. Tropical storm is also used in this region for tropical cyclones that aren't of hurricane strength. And then there's a whole superstorm is not in our vocabulary. That's a Weather Channel or, broadcast meteorologist type of thing. It's a very informal thing.
Okay, so the scientific term is tropical cyclone, but people use hurricane or typhoon depending on where these cyclones are in the world. But they are all the same thing and work the same way. Strong winds suck heat from the warm tropical oceans, which warms the air and creates a snowball effect. Fast-moving air sucks in more air and more heat until they turn into a storm. But as we emit more greenhouse gases, things start to change. There's a ton of research going into this area to better understand it. The bottom line is, cyclones are going to get worse with climate change, but not necessarily more frequent.
We don't really understand what sets the frequency of hurricanes, even in the current climate, very well. There are about 90 tropical cyclones on the planet every year. And why it's 90 and not some completely different number is not something we currently understand very well. The two things I'd say we're confident about, all of the things being equal, the storms will be more intense. The storms will have stronger winds. When you put greenhouse gases in the atmosphere, the ocean not only warms up, but the rate of evaporation of seawater increases.
The science here is complex, and I have to admit I had a hard time understanding it. But essentially, the faster the wind sucks heat from the oceans, the more energy the storm has, hence stronger winds.
The other thing we're completely confident of is that a given storm will rain more. But that's very simple physics. The warmer the air, the more water vapor it can hold. We already think that a storm like Harvey or Florence would have been very improbable even 20 or 30 years ago in terms of the amount of rain produced.
For those who are unfamiliar, Harvey and Florence were the names of hurricanes that hit the U.S. in 2017 and 2018. Professor Emanuel will also mention Hurricane Sandy, which hit the eastern U.S. hard in 2012. So, at least, scientists are confident that future cyclones will have faster winds and more rain because of climate change. That means more storm surges and more flooding.
Storm surges, in practice, are the most lethal aspect of hurricanes globally.
And what's a storm surge?
It's a tsunami. It's the same phenomenon exactly. The only difference is that it's created by wind rather than by shaking seafloor. But once it's going, it's the same thing.
So a big wave.
It's a big wave, and it has a disadvantage that it arrives in the middle of a horrible wind and rainstorm. You know, your house can withstand the wind maybe, and you decide to stay on the beach or near the coast, and the storm comes. You think the water will rise gradually, and if it does, you'll go onto the roof or something. If it's a big storm surge, you don't have a chance. People should look at videos of storm surges. There are a few out there on YouTube. You realize when you look at this, there's no way you can survive it. You can't outrun it. It's a tsunami.
The other contributing factor to this is sea level rise. Storm surges will do more damage if they're more elevated to begin with.
Sandy, if it had occurred in 1900, probably wouldn't have flooded lower Manhattan because sea level was about a foot higher than it was in 1900. For perfectly natural reasons, plus man-made climate warming. The other direct thing is flash floods, or very strong floods from heavy, heavy rain.
That's what happened in Texas with Hurricane Harvey in 2017. The slow-moving hurricane dumped rain on Houston day after day, causing massive floods and costing billions of dollars. Scientists gave storms like Hurricane Harvey about a 1% chance of happening in the 1990s. Because of climate change, this 1% likelihood has already increased to more than 5%. And by 2090, could be getting close to 20%. Now, 2090 seems far away, and it kind of is. You know, we probably won't be alive then. But if you have or will have children, then likely they and their children will be. Okay, so that's about the future. What about today?
When we talk about climate change and we want to translate that to risk, we want to know how many storms are going to be making landfall where, what their intensity will be, how much rain they'll produce, and so forth, and translate that into numbers we can understand, like economic damage.
Since the 1970s, cyclones globally have caused, okay, get this, an average of $700 billion in damages each year. That's $700 billion each year. And because more and more people are developing oceanfront property and moving to the coast, the number of people who are at risk has tripled in this time.
I mean, look, I think it's a free country. If people want to live on the coast, they should be able to. There are coastlines, the eastern side of the Philippines, for example, where there's been a more natural adaptation to a hurricane-prone coastline. There's a handful of fortresses owned by wealthy people that are really built to take a Cat 5 typhoon, which is fairly frequent there, and they do. And then there are a lot of cardboard shanties that people build and go to for 2 weeks in summer. Every once in a while it's blown or washed away. So what? It gets rebuilt. That's an intelligent adaptation to risk.
Creating hurricane-proof buildings and infrastructure is one option. There's also work to reinforce nature's ability to break storm surges or to absorb water, like with expanding wetlands. But some coastal areas are looking at just leaving.
Other parts of the world, particularly low-lying islands, climate change is the dominant consideration for looking at 20, 30, 40 years in the future. If you are on a mountainous island or high island, the Hawaiian Islands, for example, the adaptation is to retreat gradually from the coast. If you're talking about a low-lying coral atoll, sea level rise all by itself is a problem. It's already a problem in some places. And the canary in the mine is the storm, right, that just washes everything away. I mean, there are islands that they're contemplating evacuating. There's a whole island nation in the Pacific, Kiribati. they're thinking about just evacuating the entire population. It's kind of sad.
One of the purposes of science is to inform action. Scientists, planners, economists are working hard to understand how hurricanes are changing with global warming and what their impacts will be. This research can help policymakers see what their region's risks are and how people will be affected, because the risks can be really serious.
The number one thing I would say to coastal residents is if a government official tells you to evacuate, don't mess around. Get out. Get out early while you can. It may prove to be, for nothing. Maybe the storm will turn. Maybe it won't be so bad. But don't risk your life. Okay? People do get killed in these storms. That's the number one message I have.
Hurricanes, floods, and storm surges are dangerous even without climate change. But with warmer oceans and air and a higher sea level, they're predicted to get even worse. If we don't lower the amount of greenhouse gases that are in our atmosphere, this is a future that we could expect to see. As a side note, many people have reached out to us asking us what they can do about climate change. This is a great question, and we'll be releasing a mini episode that talks about just this. It'll be out soon. For now, if you're looking for more on the connection between hurricanes and climate change, and also examples of what people are doing around the world to prepare for more intense natural disasters, check out our show notes on tilclimate.mit.edu. Do you have questions about the causes and impacts of climate change? Send us a message on Twitter at tilclimate or email us at tilclimate@mit.edu. I'm your host, Laur Hesse Fisher from the MIT Environmental Solutions Initiative. Thanks to Professor Emanuel for speaking with us and to you for listening. See you next time.